Okay, grade 10s, welcome back. So we're going to continue on with chemistry unit, and we're going to go through the atomic structure and drawing of atoms. So this is a little bit of a review for grade 9, but it's setting us up for kind of some new material when we go over tomorrow, which is going to be isotopes and ions. Okay, so let's go through the atomic structure. So right here, just kind of the front page, I have a picture of what an atom looks like. So hopefully this looks somewhat familiar to you, with having our nucleus with neutrons, protons, and electrons. But we're going to go through that and we'll review everything. Okay, so recall that all living things and non-living things, with the exception of energy, are made up of little tiny spheres called atoms. So it's very hard to believe because they are so small, but everything that you look at, a piece of your computer, some water, a piece of wood, all of those things are made up of these really, really tiny spheres called atoms. Now, atoms come in different sizes, colors, strengths, weaknesses, and general abilities. Now, we call these things physical and chemical properties, and that's kind of what we went over last week, was that chemists have gone through and they've looked at all these different atoms and all the different kinds of atoms and said, what are some advantages of this atom? What are some of the disadvantages? What color is it? What strength is it? Is it bendable? Is it malleable? Does it react with water? Does it react with air? And so on. Okay. Now, there's about 118 different types of atoms, which we call elements. Okay, so elements and atoms, oftentimes we use those words interchangeably, but they are slightly different. So elements are the different kinds of atoms that we have, or the different types. So elements are the basic building blocks of everything. So if you look at yourself, you're primarily composed of carbon spheres, hydrogen spheres, oxygen spheres, nitrogen, and phosphorus spheres, or atoms. And that's what you're primarily composed of. You're just several of the spheres all connected together. Okay, so lecture 3 is all about the structure of an atom and drawing different kinds of atoms. It will be a little review from grade 9, but we're going to extend the idea into the next lesson. Okay, so although there are about 118 different kinds of atoms, known as elements, the parts of the atoms are the same. So these are going to be some key things here. Okay? These are the different parts of the atoms. So the first thing we're going to go through is the nucleus. Okay? Now the nucleus on this picture isn't actually drawn, but I'm going to draw it in there for you. So what the nucleus is just a little circle right in the middle of the atom. Right? Now inside that nucleus, we have two things. Okay? Inside the nucleus, we have protons, which are inside the nucleus. Okay? And then the other thing we have is neutrons, which are inside the nucleus. Electrons aren't. They are outside. So these are the three of the 6 components. We've got the nucleus, protons, and neutrons. Then the other things that we have electrons. So here's some examples of electrons. We've got energy rings. So that's what kind of I'm just highlighting here. So just the rings that go around. The nucleus is not considered an energy ring, okay, but the rings outside the nucleus. And then we have these thing called valence electrons, okay, and this may be a little bit new depending on who taught you in grade 9. But valence electrons are different than other electrons. These are the electrons in the outer ring. So they're only these electrons, not included on the inner ring electrons. So it would not include ones like that one's not a valence electron, that's just a regular electron. So the outer ones are valence electrons. And those are the parts of the atom. Now, the nucleus, so we're going to go through each part. The nucleus is a small, dense area, right, in the middle of the atom. Every atom contains a nucleus. So every single atom is going to contain a nucleus. And when you draw atoms, it's usually the first thing you kind of start with. So here's the nucleus, kind of the part that I just highlighted. And you can see inside the nucleus, you've got protons and neutrons. So what are protons? Well, protons are smaller subparticles. So a subparticle just means that it's smaller than an atom. So it's a part of an atom that each contain a positive 1 charge. So protons are positively charged, and that's important. Okay? Now, these are stuck in the nucleus, and they can never leave the atom. So protons are always stuck inside that nucleus. They never leave under any circumstance. Okay? So protons are. Now, the other thing inside there are neutrons. So what are neutrons? So it's just a different subparticle that contains no charge. There's no charge to it. Okay? Protons are positive. Neutrons don't have a charge at all. Now, the other big difference is they are not stuck in the nucleus, and they often enter or leave the nucleus. Tomorrow's lesson is going to talk about what happens if they enter or leave the nucleus. They develop these things called isotopes and then eventually radiation. Okay? So we've got the nucleus covered. Nucleus, protons, and neutrons. Let's talk about now the parts. So the other parts are just general electrons. So electrons are another subparticle located outside the nucleus on energy rings. Now electrons are negatively charged. Okay? So when I just say a general electron, these are the ones I'm talking about. So there's an electron, there's an electron. These are all electrons. Okay? Now, I'm not going to do the outer ring ones because those are called something special. They're called valence electrons. But just general electrons are the ones on the inner rings. Okay? Now, the other thing we have are energy rings. So these are the rings surrounding the nucleus that the electrons are stuck on. Electrons can't just float anywhere. They have to be stuck on these rings. Now, again, the nucleus is not considered a ring. But here's my first energy ring highlighted. There's my second energy ring. And this will be my third energy ring. Okay? So this atom happens to have 3 different energy rings. Now, the last one, valence electrons. What are valence electrons? Okay. Well, they're similar to normal electrons, but they're located on the outer ring of the atom. So they're these electrons right here. Right? Now, these are special electrons, which is why they get a special name, because they are able to jump from atom to atom. The inner electrons, regular electrons, usually don't. Okay? It's only the outside ones in the outer ring that start jumping from atom to atom. Okay? And when they do that, that's what a reaction is. That's what we're seeing when we see reactions. We see electrons jumping from atom to atom. Okay. So these are just some pictures of different atoms. Remember we mentioned that different elements contain slightly different atoms. Well, they're all going to have a nucleus. Okay? They all have a nucleus, which is right here. Okay? They're all going to have energy rings, which you can see. They're all going to have electrons. They all have protons. They all have neutrons. They just have different amounts of them. So something like fluorine has 9 protons. So it's got 9 protons. It's got 10 neutrons. And the number of electrons it's got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'd say it has 9 electrons. Okay. If we were being really specific, we would say, okay, there's 2 regular electrons and 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, we move over here to carbon, slightly different. It's got 6 protons, okay, 6 neutrons, and 1, 2 regular electrons, but total electrons 1, 2, 3, 4, 5, and 6. Okay, oxygen, again, slightly different. So this is why everything looks different. If you look at carbon and oxygen and fluorine, they all look different because their atoms, the basic building blocks of them, are slightly different. Okay, so our next and our last kind of thing today on today's lesson is how to draw different atoms of elements. Now, you may remember this from grade 9, but some of us may have forgotten. So we want to just review this. So there's a couple things that we need to do. Okay, now I'm going to go through this in kind of a bunch of steps. Once we get the hang of it, you won't have to go through these steps. So the first thing is you need to identify the type of atom that you need to draw. Okay, so we're just going to do one, and we're going to say we're going to do carbon. I'll pick a better color here. So we're going to draw carbon. Okay. Next thing, I need to find the element on the periodic table. Now, you can find any periodic table that you like. You can even download a periodic table, which I suggest because it's really, really handy to have. But I'm just going to show you one that I have in here. So I found carbon. Next one, use the periodic table to identify 2 numbers, atomic number and atomic mass. Okay, so I'm going to write these down: atomic number and atomic mass. Okay, so I get this from the periodic table. Go back, and I'm going to say my atomic number is 6. So I'm going to go back here, and it rounds out to 12. All right, so now I've done step 3. Step 3 is now complete. Okay. Now, step 4. I determine the proton, electron, and neutron number. So I'm going to put down my proton number, and it's positively charged. My neutron number, and there's no charge. And my electron number, and it's negatively charged. So I want to know all of these numbers. So how do I get them? Well, I'm going to use these 2 numbers that I got before, my atomic number and my atomic mass. So my number of protons equals my atomic number. What's my atomic number? 6. So my number of protons is 6. The number of electrons equals my atomic number. Right? So my atomic number is 6. My number of electrons is 6. Now, when I want to get neutrons, it's the only one where I actually kind of need to do a calculation. I need to take my atomic mass minus my atomic number. So I take 12 which is my atomic mass, minus my atomic number 6, and it happens to be 6 as well. Now, it's not always the case that all three are the same. These two will always be the same, but neutron number won't always, so you always have to do that calculation. Okay? Now we're at this point, okay, and I've got all these numbers. Okay, so I'm just going to erase some of this just for space. Okay, so I've got carbon. Okay, and I'm just going to put back that my proton number was 6, my neutron number was 6, and my electron number was 6. Okay, draw the nucleus. So we're going to draw a nucleus, and that's just a small circle, and that's not an energy ring. That's the nucleus. Okay, so draw the nucleus and report proton and neutron number. So I'm going to put P positive equals 6, and my neutron equals 6. Okay, so I've now done step 5. Draw the first energy ring and add at most 2 electrons. Well, I've got 6 electrons I need to add in here. So I draw my first energy ring, and my first energy ring can only hold 2 electrons. Well, I've got 6 I got to get rid of, so I'm going to put 1 and 2. Okay. Now I've done this step. Draw additional energy rings when full. Okay. So I've filled up this energy. So draw additional energy rings when full. This one's full because it can only handle 2. Max 8 electrons in each ring. So I can add another ring. And every other ring besides the first one I can put 8 in. Well, I've only got 4 left. Okay, I had 6 total. I've already used 1, 2. So I'm only going to add, this will be my 3rd one, my 4th one, my 5th one, and my 6th one. And now I've drawn all my electrons, all my neutrons, all my protons, and this is the drawing of carbon in our thing. So here's the periodic table, and I need to find carbon. So I'm going to find carbon. It's right here. I highlighted it. Let me pick a better color to highlight it up. It's basically number 6. I'm going to have to draw a box around it because the highlighting's not working the best. So here is carbon. I found it. Okay. So now I'm going to go back. Go back to my, and I'm going to say, okay, my atomic number is the number in the top left-hand corner. It is a solid number, so that is 6. Now, the next thing I'm going to look for is my atomic mass. And my atomic mass is always the decimal number in the box. And here it says 12.011. Well, when we do these calculations, we round them off. Okay? So this is going to round 12. All right, so we're going to be using this periodic table, and you can reuse this right from lecture, okay? As well as if you want to just kind of download that app that I told you to. It's really just any periodic table app. There's not a specific one that. And I find lithium here. All right. Okay, I apologize, just the program that I'm using. I can't see lithium on my screen, so one of the difficulties of, look at calcium. Calcium is going to be a big one. So when we look at calcium, again, because of my presenter view, I can't see calcium. So I'm going to tell you already that calcium's to just. So if we want to draw just a few more here, okay? I know I've already drawn carbon, so I'm going to draw lithium. So if I go doing online stuff, so let's do calcium instead, okay? Atomic number is 20, and its atomic mass, if we round that, is 40. Okay? So what that means, if I'm going to do this correctly, okay, so what that means is that my proton number equals 20, my neutron number is 40 minus 20, which also happens to be 20, and my electron number is 20. So now when I want to draw calcium, here I'm going to put my proton number 20, neutron 20. Okay, I apologize, it's just a little sloppy, it's just hard to draw on an iPad. And now we have to put 20 electrons. Draw my first energy ring. There's 1, there's 2. Draw my second energy ring. There's 3, 4, 5, 6, 7, 8, 10. Okay. Now, I've only got 10 electrons, but remember, I've got 20 that I need to fill up. But I've just filled up this ring, so now I have to draw another ring. And again, I can put 8 in there. So 1, 2, 3, 4, 5, 6, 7, 8. And now I still need 2 electrons left because I've only got 18 in here. So I'm going to draw another ring, and I apologize again, this is getting really sloppy. 1, 2. And there's my drawing of calcium. Okay, that's it. So my first learning check is going to be basically asking you to draw some atoms. Okay. Again, message me if you have any difficulty.